our sequence x sub n is equal to cosine 1 over n, where n is 1, 2, and so on, is a Cauchy sequence. Okay, so proof is x sub n is a Cauchy sequence if for all epsilon greater than 0 there exists an n. That's this n here is going to be an element of positive integers. So positive integers meaning 0, 1, 2, 3, and so on. Where n is, we don't know what that is. So we're trying to figure out what n is, where n and m are elements of natural numbers or counting numbers, right? Where n is greater than m. So we're talking about x sub m, right, or x sub n, where m and n either way are greater than this number n here. And that implies x sub n minus x sub m is less than, the absolute value for that is less than epsilon. So we substitute in for x sub n cosine 1 over n, and for x sub m we substitute cosine 1 over m, and that's less than epsilon. Okay, so before we get started, let's let u equal to be 1 over n, and let v equal to 1 over m. So if we use the trig identity of cosine u minus cosine v, then that's going to equal to a negative 2 sine u plus v over 2 times sine u minus v over 2. And so we're going to put this in for what we have here. So this will be the absolute value so all this is equal to the absolute value of a negative 2 sine u plus v over 2 sine u minus v over 2. Close that absolute value, and that's all less than epsilon. Alright, so from here we can go ahead and say, okay, this is absolute value, so that negative goes away, and we can move that, this is absolute value here, and we can move that 2 outside. So that's 2 is outside of the absolute value, and because it's absolute value, the negative changes to a positive. And here we have sine, and we said that u is 1 over n. So this will be 1 over n plus, and then v we said was 1 over m, and that's all over 2. And then we have sine 1 over n minus 1 over m, and that's all over 2, and that's absolute value. Okay, so let's look at some, let's analyze this further. And so if we're looking at the unit circle, right, where this is 1, we know that sine x, absolute value of sine x, is less than 1. So we're going to let sine 1 over n minus 1 over m over 2, that absolute value. So we can split that, okay? And we're going to let that be less than 1. So we're saying that this expression is going to be less than 2 absolute value sine 1 over n plus 1 over m over 2 times the absolute value of sine 1 over n minus 1 over m over 2 absolute value. And now we're saying that we're going to let this expression be less than 1, because if sine x is less than 1, then all of this is going to be even less than sine x. So that's less than 1. So we're saying that 2, I don't have enough room here. So we're saying here that 2, this expression is going to be less than 2 sine 1 over n plus 1 over m over 2 times 1. Okay, so again, since sine is less than or equal to 1, right, then this sine n minus m, 1 over n minus 1 over m, that's less than sine. So this is going to be less than 1 as well. Okay, so from here, we know, let's look at this for a moment. Okay, let's look at, for example, sine of pi over 6, that absolute value. Well, sine at pi over 6, if you calculate that out, right, that's, if you took sine pi over 6, right, and that's 1/2, right? That's 1/2. Whereas that's less than pi over 6, right? Because pi over, so this is the same thing as 0.5. Well, pi over 6, that's 0.56, and it goes on, right? So if you were to calculate pi over 6, that's 0.53, 52359, and so on. 0.52. So 0.52 is larger than 0.5. So we can say that sine of 1 over n plus 1 over m over 2 is less than 1 over n plus 1 over m over 2. We can say that this is less than this, because we can say, we know that sine of pi over 6 is 0.5, and pi over 6 itself without sine is 0.52. So we can say that this is less than this. So in that case, we can say that this expression here is less than 2 times 1 over n plus 1 over m over 2 times 1. We can drop the 1 now, and so the 2's cancel out, and so we get here 1 over n plus 1 over m. Okay, and since we know that since all of this together, right, if we go all the way back to here, right, all the way back to here, we know that this expression is less than epsilon, right? So this is all less than epsilon. So if we look at each one separately, we can say that 1 over n is less than epsilon over 2. So we can make this, we're saying this is less than this epsilon, if we made this epsilon over 2, 1 over epsilon over 2 and 1 over epsilon over 2, that this would be less than epsilon. So if we multiply it into both sides, right, and we get 1 is less than epsilon over 2 comes in, and we multiply the reciprocal, right, 2 over epsilon, multiply 2 over epsilon, then we can say that n is greater than 2 over epsilon, right? Or n is greater than 2 over epsilon. So since n is greater than big N, and so we can say that big N is greater than 2 over epsilon. Okay, so going back to up here, because I need the room, I can say that this is, so we can say that n is equal to 2 over epsilon. So we can choose n to be 2 over epsilon. Okay, so we're going back up here and we're going to put n equals to 2 over epsilon. And so from here you're going to go back and redo the proof, and you can say for x sub n is a Cauchy sequence for all epsilon greater than 0. There exists an n greater that is an element of integers. Choose n as 2 over epsilon. And then you're going to go back and you're going to do this proof again, and back to here, go through, do all this again, and when you get to here, you can say that this is less than, this expression is less than 1 over n plus 1 over n. So we're substituting, since n is greater than big N and m is greater than big N, we can say that 1 over n is less than 1 over big N. And the same thing for 1 over m is less than 1 over big N. So this expression is less than 1 over big N plus 1 over big N. And so we can substitute in our epsilon, our 2 over epsilon. We can substitute in our 2 over epsilon, and for n here, so this is 2 over epsilon plus 1 over 2 over epsilon, and so we apply the reciprocal, we get epsilon over 2 plus epsilon over 2, and that equals 2 epsilon, and we've proven it. And that concludes our video.